Hello students, this is Harish Konda. Welcome to my channel, The Chemistry Classroom. So, one thing I want to request you. So, I am very close to 100 subscribers. Please encourage me and promote my channel. Okay. So, today I am discussing about the EAMCET topics. In the previous video, I discussed within short days how to get the highest marks in chemistry. So, we will discuss the topics wise. Maximum in one video we finish one topic. So, today in EAMCET I am going to start the first topic, atomic structure. So, about the atomic structure I am discussing, it is for 2 marks. 2 marks in your EAMCET. So, it is very weightaged. In 40 marks, you are getting 2 marks from atomic structure. So, what is atomic structure? What are the important points? In this video, we are going to discuss. Okay? So, generally, before starting the atomic structure, we introduce about that one. So, generally, in the universe, everything is matter. What it is called? It is matter. In the universe, whatever it is, which is having the mass, that is called matter. So, the planets, earth, sun, moon, everything, the skies, stars, everything is called matter only, which is having the mass. Everything is matter. The matter is classified into 2. The one is called pure substance and the second one is called mixture. The one is called pure substance and the second one is called mixture. So, everything is matter. The matter is classified into 2. The one is pure substance and the second is mixture. So, the pure substance again it is classified into 2. The one is called element. We also call pure element and the second is called compound. What it is called? Compound. The compound is pure substance, pure compound, like that we discuss. So, generally, the matter, it is classified into 2. The one is pure substance and second mixture. The pure substance is classified into 2. The one is element and the second is compound. When the elements are mixed together, what you form? The pure compound you form. When the compounds are mixed, what you form? The mixture you form. The mixture is in 2 types. The one is called homolytic and the second one is called heterolytic. Homolytic mixture and heterolytic mixture. So, later in the further videos we discuss about the mixtures. So, homolytic mixture is called solutions, that we have one topic in our EAMCET also. Then we discuss. So, here the matter is classified into pure substance and mixture. The pure substance again it is classified into element and compound. The pure element and the compound. The pure element, it is a combination of same molecules. The same molecules. So, the same molecules when they are combined, what you form? The element you form. That means the element is a combination of molecules. When the molecules are mixed with the same molecules, that is alike. The molecules are alike. When they are alike, the molecules when they are combined, what you form? The element you form. The different elements when they are combined, what you form? The compound you form. The different compounds when they are combined, what you form? The mixture you form. If the mixture is homolytic or heterolytic. Okay. So, here the molecules when they are combined, you are forming the element. How you are able to know? So, when the element is divided, into the particles, so you are getting the last particles, what they are called? Molecules. What they are called? Molecules. So, molecules are combined to form the element. Elements are combined to form the compound. Compound is combined to form the mixture. Mixture is the matter. That's why the matter fundamental particles are called molecules. But further the science is developed. The molecules can be divided. the molecules can be divided into the atoms. The same alike atoms, homoatom. Homoatoms means same atoms. When the same atoms are combined, what you form? The molecule you form. The molecules are combined, element you form. The elements are combined, compound, compound combined, mixture, mixture is the matter. So now the definition is changed. What it is? The fundamental particles for the matter is called atoms. So why? Because the same type of atoms, the same alike atoms. For example, you see the hydrogen atoms. When the hydrogen atoms, they are combined, the two hydrogen atoms are combined, what you form? The hydrogen molecule you are forming. The hydrogen molecule, and one more, for example, oxygen atoms. When the two oxygen atoms are combined, what you form? The oxygen molecule you form. The oxygen molecule and the hydrogen molecules are combined, what they form? The hydrogen element and the oxygen element. When these two elements are combined, what you form? The water you form. Like that the compounds are formed. So here the matter is classified into pure substances and mixtures. The pure substance is the elements and compounds. The elements are the combination of molecules, alike molecules are the same molecules. The molecules are divided into the atoms. So the atoms are the fundamental particles for the matter. So the science is developed about the atoms we want to discuss. That is called atomic structure. That is our topic. So the atoms are invisible. What we think, the atoms are undividable particles. We are not able to divide the atoms. That earlier stages we think. But the atoms can be dividable. The atoms also can be divided into two. The one is called stable particles and the other one is called unstable particles. What they are called? Unstable particles. The atoms are divided into two. The one is called stable particles. The other one is called unstable particles. So what they are involved in the structure of the atom is called stable particles. What they are not involved in the structure of the atom, they are called unstable particles. These unstable particles are in the nuclear reactions only they appear. For example, mesons, positrons, like that so many particles, nearby 60 particles we have. They are not interfering, they are not involved to form the structure of the atom. That's why they are called unstable particles. So what is the second one? It is stable particles. The stable particles are involved to form the structure. So the atoms are invisible, so the particles also invisible. Here we have three stable particles. The one is called electrons, and the second one is called protons, and the third one is called neutrons. So the atom, how it is formed? With the stable particles it is formed. So what are the stable particles? You know, that is electrons, protons and neutrons. So what it means, when you want to form this atom, so these three particles are involved. These three particles are involved to form the structure. So atoms are formed. The atoms are forming the molecules are forming the elements are forming the compounds are forming the mixture is the matter. That means the definition automatically is changed. For the matter, what are the fundamental particles? They are electrons, protons and neutrons. Understood? I repeat, the matter I am classifying into two. The one is pure substance and the second is mixture. So the pure substance, again it is classified into two. The one is elements and the second is compounds. And the third, the elements are dividable. They are dividing into molecules. So when you are dividing the elements, what you are forming? The molecules you are forming. The molecules, what we thought? The undividable particle is called molecule. But the science is developed. The molecule also divided into the atoms. The atoms are divided into the particles. The stable particles are three. The electrons, protons and neutrons. They are involved in the structure of the atom. So you have to know about these particles, electrons, protons and neutrons. Now one by one we discuss. So here I given some information about the electrons, protons and neutrons. They are very useful for your EAMCET. So I am explaining about that electrons, the first particles. So here you see the electrons are introduced by J.J. Thomson in the J.J. Thomson laboratory. Here we have an assistant that is called William Cook. The William Cook done one experiment that is called cathode ray experiment. What is the experiment? It is cathode ray experiment. Based on the cathode ray experiment results, he concluded the electrons. The electrons, that is cathode ray experiment, he concluded the electrons. So that's why they introduced by J.J. Thomson. The electrons are introduced by J.J. Thomson. The electrons are negative particles, negative charged particles. What is the charge of that electrons? It is minus 1.6022 into 10 to the power of minus 19 coulombs it is. So it is the units coulombs. So the charge is minus 1.6022 into 10 to the power of minus 19 coulombs. That is equal to minus 4.802 into 10 to the power of minus 10 ESU, electrostatic units. So generally it is one electron charge. So what we have to get? The charge is introduced by R.A. Mulliken. So by oil drop experiment, he introduced the charge. The charge is introduced by R.A. Mulliken. So what is the experiment he done? Oil drop experiment. Based on oil drop experiment, he introduced the charge. So here for one electron it is the charge. Generally we have one mole of electrons. So 1 mole of electrons are having one charge that is called specific charge. The specific charge of the electron, that is E by M. E is the charge of the electron, M is the mass of the electron. So you are getting the specific charge 1.758 into 10 to the power of 8 coulombs per gram. So it is the details about the electrons. I repeat, the electrons are introduced by J.J. Thomson. So the cathode ray experiment, the charges are given. That oil drop experiment, R.A. Mulliken is the charge introducer. So that is specific charge. So respectively, the specific charge is introduced by the experiment, that is mass, that is the meter, that is mass spectrometer. Based on the mass spectrometer, he identified the specific charge. And the second particles, they are called protons. The protons are introduced by Goldstein. So the experiment is called anode ray experiment. It is also called canal ray experiment. It is reversed to the cathode ray experiment. The anode ray experiment, it is cathode ray experiment. The anode ray experiment is introduced the protons. That is called canal ray experiment also. The charge of the particle, the protons are positively charged. The charge is equal to the electron charge only. But it is minus charge, it is plus charge. What is the proton charge? It is 1.602 into 10 to the power of minus 19 coulombs. It is a positive charge. The proton charge is plus 1.602 into 10 to the power of minus 19 coulombs. So it is equal to plus 4.802 into 10 to the power of minus 10 electrostatic units, that is ESU. So mass of the proton is equal to 1.6762 into 10 to the power of minus 24 grams it is. So it is equal to the hydrogen weight. It is equal to the hydrogen weight. What is the weight of hydrogen? It is 1.007276 AMU, atomic mass units. So it is equal to the hydrogen mass. So that's why the proton mass and hydrogen mass are equal. Sometimes the hydrogens are called protons also. So here the specific charge already we discussed. The charge by the mass is called specific charge. The specific charge of the protons is equal to 9.58 into 10 to the power of 4 coulombs per grams. So it is about the protons. And the third particles we know, that is neutrons. The neutrons are introduced by the Chadwick. So here the neutrons are zero charge. So automatically the specific charge also zero. The mass of the neutrons is equal to the protons only. That is nearby 1.008 something AMU. So it is about these particles. take this screenshot first. Okay. So atoms are having the particles, that is electrons, protons, neutrons. That how it is introduced already we discussed. So based on that electrons, protons and neutrons, so here we are getting some properties for the atom. The first property is atomic number. The atomic number we denote with Z. So generally the atomic number is equal to the protons number or equal to the electrons number which are present in the atom. Why? Because the protons are not changed. So every atom is identified with the protons only. For each and every atom, for element is having the fixed number of protons. Based on the proton number only you are identifying the atom. For example, hydrogen, here we have hydrogen in one proton only. So which is having one proton in the atom, that is hydrogen. For example, oxygen, by the oxygen what you have the protons? 8 number of protons. So 8 number of protons means it is oxygen only, wherever it is in the universe, whatever it is. So which is having 8 protons in the universe, that is oxygen only. Why? Because based on the proton number only you are giving the atomic number Z. The atomic number Z is indicating the atom. So the protons or the number of electrons. The protons and electrons are equal. Why? Because the atoms are having zero charge. The atoms are not having the charge. That means the protons are positive, so electrons are negative. So if they are equal, automatically the atom is getting zero charge. That means number of protons or number of electrons indicating the atomic number, that is Z. And what is the second property? That is mass number. So generally the protons are having the mass and the atoms, electrons are having the mass. At the same time neutrons are having the mass. So the atom is having these 3 particles, electrons, protons and neutrons. So these 3 particles combinedly they are getting some mass for the atom. That is atomic mass or mass number of the atom. That is denoted with A. So generally the electrons are very negotiable mass it is. 1 by 1837. 1 by 1837 of proton mass is equal to the electron mass. So electron mass is equal to 1 by 1837 of proton mass. So it is very less value only. When it is equal to 1837 electrons, you are getting 1 unit. So that means the electron mass is negotiable. There what we consider the proton mass and the neutron mass only we consider. Generally already we discussed about the proton mass, it is equal to 1.007 something, so AMU. So that is equal to 1 only, that number of protons equal to the number of protons only. So the number of protons and number of neutrons are equal to the mass number, that is A. That A equal to Z indicates the number of protons, that is atomic number, and the number of neutrons, it is N. So A equal to Z plus N. The A equal to Z plus N indicates the mass number. So from there you can count the neutrons. How many neutrons are present in that atom you can count. So that A minus Z, atomic mass minus atomic number indicates the neutrons number. So based on these atoms, electrons, protons and neutrons, that atoms are getting some properties. Already we discussed about the atomic number and mass number. So including that, so we are getting some more type of properties. The one is isotopes and isobars and isotones. What they are we see. So generally we discuss the first one, isotopes. So generally isotopes, what it is the meaning of isotopes? So which is having the same atomic number. The atomic number is same. But what they are different in the mass number. The mass is different. The atomic number is same, but the mass is different. For example, you see the hydrogen atom. The hydrogen atom atomic number is 1. The atomic number is 1. Here this hydrogen atom atomic number also 1. This hydrogen atom atomic number also 1. But what is the mass of that hydrogen is 1. Here the mass of hydrogen is 2. Here the mass of hydrogen is 3. So these 3 atoms are getting different masses. The atomic number is same, but the mass is different. So here subscript and superscript we have 2. The subscript indicates the atomic number, superscript indicates the mass number. The hydrogen is having 1 atomic number and 1 mass number. This hydrogen is having 1 atomic number, 2 mass number. This hydrogen is having 1 atomic number and 3 mass number. So they are different with atomic numbers are same, but the mass number is different. Same similarly the chlorine 17 and 35, the chlorine 17 and 37. So generally, so in the molecules, in the element, how many atoms are present? So with these isotopes, how many they are present, based on that we will get the average mass. So for generally in the hydrogen element, the mostly the hydrogens are in 1H1 only. So that's why we are taking the mass of hydrogen is 1. But here you see the chlorine. So one is with 35 and one is with 37. They are equal in the chlorine element. The two are equal. With the different masses we are equal. So that's why we are getting the average mass. What is the average mass? The 35 with half, the 37 with half. So what is the average? It is 35.5. So like that we are getting that mass. That is called average mass also. So here isotopes, they are having the same atomic number and different mass numbers are called isotopes. So next one is isobars. The mass is same but the atomic number is different. Here you see the example, argon, potassium and calcium. The atomic number of argon is 18. Potassium atomic number is 19, the calcium atomic number is 20, but the three are having the same mass, the 40, 40, 40 only. So here argon is having the 40 mass, the potassium is having the 40 and calcium also having the 40. So they are called isobars. One more example also we could take, the oxygen 8 and 18, the fluorine 9 and 18. The two are having the same mass but the atomic number is different. So that's why they are called isobars. And the last it is isotones. So here the mass is different and the atomic number also different. The atomic number is different. At the same time the mass number also different. For example, you see the carbon 6 and 14, the nitrogen 7 and 15, the oxygen 8 and 16. So what is the neutrons number? Atomic mass and atomic number. Atomic mass and atomic number indicates the neutrons. So here you see the 14 minus 6 or 15 minus 7 or 16 minus 8 indicates the neutrons. They are equal neutron. So in the carbon, how many neutrons you have? That is equal to the nitrogen, that is equal to the oxygen also. So they are having different atomic numbers, different mass numbers, but the neutrons number is same only. Same silicon, phosphorus and sulfur, the atomic number is 14, 15 and 16, but the mass 30, 31, 32, they are different in the atomic number, they are different in the mass number, but the difference, the mass and the atomic number difference, that is neutrons are equal. Here 30 minus 14, 31 minus 15 and 32 minus 16 is same neutron numbers. So the neutrons are same, that's why they are called isotones. Now take the screenshot. Okay. So we are discussing about the atom. So atom is having the particles, electrons, protons, neutrons. So how they are accommodated? So generally the atom is invisible. So we are not able to see that one. So to see the structure of the atom, to elucidate the structure of the atom, we need the light. Why? Because if we focus the light on the atom, you can see. So to learn about the structure of the atom, compulsory we have to learn about the light. The light is called EMR, electromagnetic radiation. What it is called? EMR, electromagnetic radiation. So when the energy particle, generally the charged particles, whatever the charged source, when it is getting energetic, high energetic, it starts vibrating. The charged one, the charged source is called starting vibration. So when it is vibrated, it emits some radiation. That radiation is called EMR. Why? Because that radiation, the wave is having two, the one is electric field and the second is magnetic field. They are perpendicular to each other. So one electric field and magnetic field is propagated. The electric field and magnetic field is propagated. That's why they are called EMR. That is the nature of the light. The light we have to discuss first. Why? Because when the light is focused on the atom, then only you can observe about the atom. You can elucidate the atom structure. So we need about the information of EMR. So here about the light we are discussing. Generally, the electromagnetic radiation is emitted. The EMR, electromagnetic radiation is emitted, is a wave. It is propagated. That wave is having some properties. About that properties now we are discussing. The first property is wavelength. It is very important to the EAMCET. Why? Because the problems can be framed from this topic. So here the wavelength, it is called lambda. So what is the wavelength? It is the distance between two neighbor towers or crests in a wave is called wavelength. So here you have a wave. For example, saying here you have a wave. So what you are doing? The 2 points, what you are calculating, the distance you are calculating. The distance is called the lambda. The 2 towers or the 2 crests you are calculating. So the distance between 2 towers or the distance between 2 crests is called the wavelength. It is denoted with lambda. So it is the units for the lambda is meters, centimeters, angstroms, nanometers, mu, like that you are discussed. So what are the values about the angstrom and nanometers, and nanometer you can know the meters and centimeters, like that the values are given. 1 angstrom equal to 10 to the power of minus 8 centimeters or 10 to the power of minus 10 meters. At the same time 1 nanometer equal to 10 to the power of minus 9 meters or 10 to the power of minus 7 centimeters. 1 nanometer equal to 1 meter of mu. So that is 10 to the power of 10 angstroms. 1 mu equal to 10 to the power of minus 6 meters. Like that the data is given. So at the same time the wave is having one more property, that is called frequency. So what is the frequency? The number of waves. The number of waves they are passed through a given point. A certain point we are here, the certain point we are making. From the point the wave is traveled. From the point the wave is traveled, the number of waves what they are traveled, number of lambdas what they are traveled in a given from a point in a 1 second. In 1 second, how many waves are traveled from that point is called the frequency. Then mu, it is denoted with mu. So what are the units per second it is? So cycles per second also, they are called CPS. They are also denoted with H. The units for H, 1 CPS equal to 1 H. 1 cycles per second is equal to 1 H. Like that the property frequency we discuss. And the next property is wave number. So what is the wave number? It is reciprocal to the wavelength. The reciprocal to the wavelength is called wave number. So it is 1 by lambda. That means 1 by centimeters or meters. So centimeter universe or meter universe. So generally the wave, the nature of the wave, the nature of the light we are discussing. The nature of the light is the EMR, electromagnetic radiation. It is having 3 properties, the wavelength and the frequency and the wavelength. So generally, so when that light we are discussing, so we have to discuss some more points about that one. So it is the black body. So when your light is fallen from substance, the everything, whatever the radiation is fall, that is completely observed. The radiation is observed by that compound or by that one, by that body. So it is capable to observe everything, whatever it is on the substance or whatever it is on the body, it is completely observed, and whatever it is observed, it is completely emits also. So whatever it is observed, it is emits also. That type of body is called black body. So the black body, we have one example. So that one halo metallic sphere we take. So in the halo it is inside, what we do? The platinum black coat we do. The platinum black coat, and one hole if we form, so that is acts as a black body. So that is the black body. What is the black body? Whatever the radiation fall on that body, it completely absorbs. At the same time, it completely emits also. Such type of bodies are called black bodies. So here we are getting one more information about the light, that is Planck quantum theory. So the Planck is introduced the quantum. So the radiation is having some energy. That energy we have to calculate. The energy is calculated by the Planck. So it is called Planck quantum theory. The energy of the radiation is equal to the h nu. So what is nu here? We know already, that is frequency. It is c by lambda. Why? Because so we are getting the lambda is inversely proportional to the nu. The frequency and the length is inversely proportional. The nu is inversely proportional to lambda. So it is, so nu is proportional to 1 by lambda. So for removing that proportionality, to equal the proportionality, what you do? One constant you multiply, that constant is c. So nu equal to c by lambda. There you substitute in the nu. So automatically what you are getting? H into c by lambda. So h into c and nu bar also. What it is nu bar? The wave number. So it is reciprocal of wavelength. So at 1 by lambda you can use nu number also. So one more equation you are getting, h into c into nu bar. The h is the Planck constant and c is the velocity of the light, and here it is the nu number. It is wave number. So there the h is Planck constant. The value of that h Planck constant is 6.625 into 10 to the power of minus 27 x per second. At the same time, so 6.625 into 10 to the power of minus 34 joules per second also. So they are the informations about the light. So about the light we are discussing. When the light is exposed to a clear metallic surface, so what happened? They eject the electrons. That effect is called photoelectric effect. The light is having some energy. That light is having some energy. When it is exposed to the light metallic surface, what happened? They are ejecting the electrons because of the energies absorbed by the atoms which are present in the metal. So they are absorbed the energy and they are ejecting the electrons. That effect is called photoelectric effect. Generally alkali metals, that is potassium, cesium, like that metals, they are observing that light, and they are ejecting the electrons. Such type of effect is called photoelectric effect. Based on the photoelectric effect, what you are getting concludes, that is that energy, the light is having some energy. That energy is equal to h nu. That energy is equal to work plus kinetic energy. Why? Because the light is focused on the metallic surface. So the metallic surface, when they are focused, when they are exposed, they are releasing the electrons. So some work is done and the electrons are getting some kinetic energy and they are releasing. So that energy what we supplied is equal to W plus Ke. W is the work done. So here the Ke is kinetic energy. The total energy what we supplied of the light is equal to W plus Ke. So that effect is called photoelectric effect. So here the photoelectric effect is directly proportional to the intensity of the incident light. So what we focus the light, so that light is directly proportional to the intensity of the light is directly proportional to the photoelectric effect. So how much intensity is increased, that much electrons are released. So similarly, that photoelectric effect is directly proportional to the frequency of the light what we focus. The frequency is high, that means the energy is high, so automatically the photoelectric effect is high. So the photoelectric effect is directly proportional to the intensity of the incident light and frequency of the incident light. So the photoelectric effect indicates the light is having some energy. So on the metal surface when it is placed, automatically the electrons are released. What it indicates? They are having some energy. So here generally the light, about the light when we are discussing, we have to discuss about the spectra of the light. So generally it is electromagnetic radiation. So when you pass from a spectrometer, so you are getting some spectra. The spectra is in two types. The one is called continuous spectra. The second is called line spectra. The first one is called continuous spectra and the second one is called line spectra. In the line spectra, you have the one is emission spectra and the second is absorption spectra. These two are called line spectra. Generally the atom, when you expose the light to the atom, so you are getting the emission spectra or the absorption spectra. That means the atom is giving line spectra. generally from the source of the sun. For example, the sun, from the sun the light is released. So when the light is released from the sun, from the source, you are getting the continuous spectra. In that we have so many variations, so many variety of radiations we have. That radiations, it is increasing order. The wavelength, when you increasing the order, if you are arranged, that is gamma rays, then X-rays, then UV rays, visible rays, infrared and radio rays. Like that, the wavelengths, when you are increasing in the order, you are getting one continuous spectra you are getting. In the visible rays also, you are getting one VIBGR. Violet, indigo, blue, green, yellow and orange. You are getting one VIBGR also. This completely it is called continuous spectra. So, when the light is exposed to the atom, so we are getting two type of spectra. The one is called emission spectra and the absorption spectra. Based on this line spectra, you can introduce the structure of the atom. The structure of the atom depends on the spectra only. Based on the spectra, the study of spectra, you can introduce the structure of the atom. The Bohr, like that scientists, they are introduced based on the spectra only, they are introduced the structure. So based on the emission spectra and the absorption spectra, you are getting the lines. Their lines are in different region you are getting. So what the lines you are getting? The Lyman, Balmer, Paschen, Brackett, Fund, like that you are getting the lines. The lines, the Lyman series, it is in the UV region. The Balmer series, it is in the visible region. And Paschen series, it is very near to the infrared. And the Brackett, it is in the infrared. And the Fund, it is far away from the infrared. So like that, different regions you are getting one spectra. The Lyman lines you are getting there in UV region, in Balmer, like that the spectra you are getting. So in the lines, in the spectra, you are getting some lines. In Lyman you have so many lines. So in different energy levels, you are getting the electron, it is excited to the different levels and it is coming to the ground state. When it is coming to the ground state, you are getting the lines. So in that lines, it is in the Lyman strain. If it is comes to the first ground state, so you are getting the Lyman series. Lyman series, the first line indicates N2 minus N1. That means from the second orbit to the first orbit, the electron is coming. The excited electron is completely coming to the down state. So N2 minus N1, it is 1. The first line indicates the 1. The second line is HB. So H beta and H gamma, H delta, H infinitive. Like that, so many lines you are getting in the Lyman series. Like that, so many series you are placed here. Lyman, Balmer, Paschen, Brackett, Fund. The lines you are getting N2 minus N1 is equal to 1. It indicates the first line. N2 minus N1 is equal to 2. It indicates the second line, third line, fourth line, and infinity lines you can get. So it is the Lyman series. Similarly, Balmer, Paschen, Brackett, like that you are getting. So maximum number of lines from the nth line, nth orbit to nth energy level to the ground level. If it comes to the nth level to the ground level, you are getting number of lines. How many number of lines you are getting? Based on the principle you can calculate. That principle is equal to n into n minus 1 by 2. Based on this principle, how many lines are appeared in that one? So in Lyman series, how many it is appeared? In Balmer, how many it is appeared? You can calculate. So similarly, maximum number of lines from nth to n1 level. So that is equal to sigma n2 minus n1. Based on these two principles, you can calculate the lines. So in the Bohr atomic model, you are getting different lines. Then only we discussed Lyman, Balmer, Paschen, Brackett, Fund, like that. The lines. So you are getting the wave number for that lines also, the frequency or the lambda also. So here we are getting one principle for the wave number, nu bar equal to R into 1 by N1, N2 minus 1 by N1. So the here R is called Rydberg constant. The principle is called Rydberg principle. Here nu bar, for the nu bar wave number, you are calculating one principle. Here R into 1 by N2 minus 1 by N1. So here R is called Rydberg constant, that is equal to 109,677 per centimeter. So based on this principle, you can calculate the wavelengths. Wavelengths of different lines. Lyman, Balmer, Paschen, Brackett, Fund. You have so many lines. So that lines wavelength you can calculate by this principle. So here for the hydrogen like atoms also you can calculate. So nu bar equal to here Z square you are using. Z square into R into 1 by N2 minus 1 by N1. So if it is hydrogen, it is 1. Z equal to 1, atomic number is 1. So 1 into 1, it is 1 square, it is 1 only. So you are getting this principle. If it is the different hydrogen like atoms means it is lithium plus like that atoms here which is having 1 electron in the outer shell. So the hydrogen like atoms also you can calculate the lines which are framed in the spectra, that nu bar equal to Z square into R into 1 by N2 minus 1 by N1. So they are the, it is for the hydrogen atom, it is for the hydrogen like atom. So in one electron, if you have one electron, that is hydrogen. So if you have same similar one electron, so that they are called hydrogen like atoms, that is lithium plus. So like the lithium plus 2, like that helium plus, like that you have, they are called hydrogen like atoms. For that nu bar equal to Z square into R into 1 by N2 minus 1 by N1. Based on this Rydberg principle, you can calculate the wavelengths for that lines also. So generally, so based on this total, the spectra like that range, so you are getting the structure. So you are getting the atomic structure. For that atomic structure, what you know very well. So in the center you have the nucleus. In the nucleus you have the protons. Around the nucleus you are getting the electron. So that electron is revolved in the orbits. The electron is revolved in the orbits. So from the center, what is the distance of this electron? The orbits, they are called orbits. They are the fixed paths. They are called orbits. That's Bohr atomic model. So we can calculate the atomic radius from the center to the radius. The electron which is revolved in the orbit. For that we can calculate the radius also. The radius of the orbit is equal to 0.529 into 10 to the power of minus 8. It is n square centimeters. So there if you substitute the n square, automatically you get the radius of the orbit. For example, for the first orbit you can calculate how it is 0.529 into 10 to the power of minus 8 into n square, n equal to 1. So when you substitute n equal to 1, it is 1 square. So automatically what you get 0.529, it is angstroms. The 10 to the power minus 8 is nothing but angstroms only. So 0.529 angstroms. Like that you can calculate the various orbits radius also. So what is your principle? 0.529 into 10 to the power of minus 8 n square centimeters or 0.529 into n square angstroms. So if you substitute the n, so automatically the radius which varies the orbitals, various orbits, so you can calculate the radius also, that is radius principle. Same similarly in the electron, when it is revolving in that orbit, it is having some energy. That energy, it is in the kinetic energy or potential energy. The total energy we can calculate. So the delta E, that is energy difference between various orbits, is equal to E2 minus even always it is h nu. Now only we calculated the Planck constant. So Planck energy, so that is h nu, it's called photon energy. The energy is called photon energy. That delta E is equal to E2 minus E1, that is h nu, that is photon energy. The Ke, the kinetic energy of that electron, we can calculate by the principle Z into E square by 2R. So Z into E square by 2R is nothing but the energy. So the Ke, kinetic energy of the electron, we can calculate. Z, here the Z is the atomic number, E is the charge of that electron, and R is the radius. Already we calculated the radius. So Ke of electron is equal to Z into E square by 2R. So potential energy also we can calculate. What is the potential energy of that electron? Minus Z into E square by R. That kinetic energy is Z E square by 2R. The potential energy is minus Z E square by R. So the total energy is equal to Ke plus Pe only. So automatically what you are getting? Minus Ze square by 2R. That energy, we can calculate the total energy of the electron which is present in the orbit. We can calculate with this principle, minus Z square by 2R. Z is atomic number. There the R is the radius for the first orbit, for the second orbit, for the third orbit. We can substitute the R values. So there from you are getting some energy levels, energies. So here that is minus 2.179 into 10 to the power of minus 11 by n square, that is x in the x, it is equal to the joules. We can calculate minus 2.179 into 10 to the power of 18 by n square joules, or it is equal to minus 13.6 n by n square electron volts EV. So mostly by this we can calculate the energy minus 13.6 by n square electron volts. At the same time minus 313.6 by n square kilocalories it is. Similarly in kilojoules also we can calculate minus 1312 by n square kilojoules per mole. So like that the energies for that electron you are calculating. There in the center you have the protons, and the electrons are revolving in the orbits. In various orbits the electrons are revolving. For that electrons you are calculating the radius. For that electrons you are calculating the energy. The kinetic energy you can calculate by the principle. The potential energy you can calculate by the principle. And the total energy also you can calculate by the principle. The kinetic energy is Z square by 2R. The potential energy is minus Z square by R. And the total energy of that electron is equal to minus Z E square by 2R. So from there you are calculating so many energies. For nth hydrogen, equal hydrogen atoms also you can calculate. So the same value 2.188 into 10 to the power of minus 11 by n square is into Z square. If you use the Z equal to 1, the same energy you are getting. If the Z is equal to 2, 3 like that you can calculate. For hydrogen like atoms also you can calculate the energies. So like that you calculating the energies. Okay. So the structure we are discussing, the Bohr atomic structure we are discussing. So in the center you have the protons. So around the protons the electrons are revolving in orbits. So for that orbits we are calculated the radius. For the orbits we calculated the energies. So to get the complete structure of the atom, so we are indicating. So here the electrons, how they are oriented, the particular address, what is the address of that electron we can determine with the quantum numbers. The quantum numbers will give the particular address of the electron. For example, where you are located, that means I am in India, I am in Telangana, I am in Warangal. So like that you are discussing. Similarly the address we are discussing. So the quantum numbers will give the complete address of the electron. How it is oriented in that atom, it will give. The quantum numbers will give. The quantum numbers are 4. The one is principal quantum number, and the second is azimuthal quantum number or angular momentum quantum number. The third it is magnetic quantum number, and the fourth it is spin quantum number. These 4 quantum numbers will give the particular address of that electron, where it is located, where the electron, how it is oriented. Like that, that complete address it will give. The first one it is principal quantum number. The principal quantum number is introduced by Niels Bohr. That principal quantum number will give the size and energy of the orbit. So very first the electron, where it is located, in the orbit it is located. In the first orbit it is located, or in the second orbit it is located, or in the third orbit it is located. Based on that you are getting the size of the atom. At the same time the electron, when it is located in that orbit, what is the energy of that orbit also you can calculate. Why? Because it is denoted with n. So the n only give the radius, that is 0.529 into n square angstroms only we discussed. The energy also we discussed. Similarly the n will give, the principal quantum will give the size and energy of the orbit. The radius and the energy of the orbit it will give. So the first one, principal quantum number. The principal quantum number is introduced by Niels Bohr, and it will give the size and energy of the orbit. So in that orbit, where it is located, the azimuthal quantum number will give the second address. The azimuthal quantum number will give the shape of the orbitals. In that orbit, which orbitals it is located, like that the information is given by the azimuthal quantum number or angular momentum quantum number. It is introduced by the Sommerfeld. So based on the azimuthal quantum number, we can get the shapes of the orbitals. It is denoted with L. So the L, based on the L value, you are calculating the shapes. You can calculate the shape of that orbitals where the electron is located. It is a second quantum number. And the third quantum number is magnetic quantum number that is introduced by Land. It is indicating the orientation, how it is oriented, the orbitals. So it is the subshells. In the subshells, how it is located, how is oriented in s orbital, in p orbital, in d orbital, in f orbital. Like that, the orientations you can calculate by the magnetic quantum number. And the last, it is spin quantum number. It will give the Goldschmidt and that Uhlenbeck is given that introduce the spin quantum number in that orbitals, how that electron is direction, how the electron is getting spin. There is plus spin or minus spin. It is in the clockwise or it is in the anti-clockwise. It will give the information by the spin quantum number. So like that, the four quantum numbers are giving the particular address about the electron, the principal quantum number, azimuthal quantum number, and magnetic quantum number, and the spin quantum number. So there the electron, based on the electron, we can calculating this quantum numbers. These three are supported that for the quantum number. The one is de Broglie wavelength, and the next one is Heisenberg uncertainty, and Schrodinger wave function is supported the quantum numbers. Based on the three principles, we are getting conclusive about the quantum numbers. The one is de Broglie wavelength. The electron is having the dual nature. The electron is a particle, but it is traveled in the wave nature. So it is having the dual nature. The de Broglie wave theory will give the wave dual nature of the electron. It is lambda equal to h by mv or h by p, that equal to h by root of 2m into ke. That electron, how it is, that electron dual nature is introduced by de Broglie, and at the same time Heisenberg uncertainty. When the electron is traveling towards that, when the electron is oriented, when the electron is revolving towards the nucleus, the electron at a time we are not able to calculate the status, at a time we are not able to calculate the velocity. The two are not, the station and the velocity is not, where the position and the velocity at a time you are not able to calculate. So it is some uncertainty will occur. If you want to calculate the position, the velocity will change. If you want to calculate the velocity, the position will change. There is the uncertainty in the station, position, or uncertainty in the velocity also. So we are getting one principle that is called Heisenberg uncertainty. The delta x, it is a variations in position, and delta p, it is variation in the angular momentum. So here delta x into delta p, it is greater than or equal to h by 4 pi, or delta x into m into delta v. Why? Because p equal to mv, there m is not changed, it is a constant value, only velocity will change. So it is m into delta v, delta x into m into delta v, that is greater than or equal to h by 4 pi. So at the same time Schrodinger wave function. So you are getting one principle. Based on this principle, you are getting the orientation of that electron, dou square psi by dou x square plus dou square psi by dou z square plus dou square psi by dou z square plus 8 pi square m by n square into e minus v psi, that equal to 0. There the psi is called wave function. So in the x orientation, y and z, in the three axis, how it is oriented, so we can calculate by the Schrodinger wave function. Based on the psi value, you are getting the orbitals, because the psi value, so psi square is the 0, so psi square value will give the orientations, the how it is shaped. So everything is given by the Schrodinger wave function. So like that we can calculate. So in the Schrodinger equation, the psi indicates the amplitude of the wave. So the psi square value indicates the probability of finding electron. The maximum probability where the electron is located, that psi square will indicate the probability of the electron. Based on the psi square, you are indicating how the probability where the electron will occur. So the psi square value, if it is 0, then that is called nodal plane. That area is called nodal plane, where the probability of finding electron is 0, the psi square is 0, that plane is called nodal plane. So we can calculate the nodal planes for different orbitals. If L equal to 0, that is s orbital, the nodal plane is 0. If L equal to 1, the nodal plane is 1. So for the p orbital, so nodal plane 2 for the d orbitals, like we are calculating the nodal planes. So here, based on this all, you can electron, how it is located, where the address is located. Now only we discussed the quantum numbers will indicate the address. So like that, how the electrons are arranged, how the electrons are oriented in that particular atom, we can give by the electronic configuration. So how the electrons are accommodated in various orbits, so they are accommodated. So based on these three principles, how the electron is accommodated, we can calculate. That is called electronic configuration. For the electronic configuration, we have three principles. One is called Pauli's exclusion, and the second is called Aufbau principle, and the third is called Hund rule. So here you see the Pauli exclusion. Generally, the four quantum numbers are not equal to 2 electrons. In the same orbital, if you have 2 electrons, the 2 electrons are not equal, the 4 quantum numbers are not equal. At least the 2 electrons, they differ in spin quantum number. They are oriented differently. One is having the clockwise, the other one is having the anti-clockwise. At least they have to differ in the spin quantum number. In one orbital, if the 2 electrons are located, the 2 electrons are not having the same quantum number. The 4 quantum numbers are not in same. So at least it has to differ in the spin quantum number. That rule is called Pauli's exclusion rule. That is Aufbau rule. Next rule is Aufbau rule. So when you have to locate the electron, where the electron is arranged, so based on the orbital's energy only, you can arrange the electrons. Less energetic orbitals we fill first, after that only next orbital we can fill. So based on the n plus L value, you are arranging, you are increasing order, you are arranging the orbitals, then electrons are located in 1s orbital, it is less energetic. Why? Because n plus L value, n equal to 1, it is s orbital, L equal to 0, so it is 1 plus 0, it is 1, then 2 plus 0, it is 2. Like that we are increasing order, we arrange in increasing order, 1s, 2s, 2p, 3s, 3p, like that we are arranged the orbitals increasing energy, increasing level. So that is Aufbau principle. Very first 1s orbital we fill first, then 2s orbital, then 2p orbital, then 3s, then 3p, then 4s, like that we fill the electrons. That is Aufbau principle. Based on the energy you can calculate, based on n plus L value, we arrange the orbitals in increasing order. The last rule is called Hund rule. So in the orbital, when you are arranging the electron, maximum multiplicity. So how many electrons can be accommodated? In s orbital you can accommodate only 2 electrons. In p orbital you have 3 suborbitals, px, py, pz. So each orbital you are accommodating 2 electrons. So maximum 6 electrons can be accommodated. In d orbital maximum 10 electrons can be accommodated. In f orbital maximum 14 electrons can be accommodated. So maximum multiplicity, you can arrange how many electrons are arranged in that orbital. By that Hund rule only we can calculate. If they are degenerated, equal energetic orbital, for example px, py, pz. So if the 3 orbitals are equal energetic, so when you are filling the electrons, the very first 1 electron should be filled, then only that next electron will be coupled. So that is called Hund's rule. Based on the 3 rules, we can arrange the electrons. So that is called electronic configuration. So like that, the atomic structure we discuss. So I hope you understood the atomic structure. You go through that notes and probably, so you take all screenshots. So by that easily you can practice and you can attempt the questions. So don't forget, please like, share and comment and subscribe. Don't forget to bell. Thank you.